Hi, and welcome back. Today, I wanted to show you how to look at the MyHappyGenes reports with your patients. This is kind of a really important area, and it's an important skill to learn so that you can really give your patients a sense of what they're looking at there and how important it is, and how it can lead them toward understanding what you're doing with MyHappyGenes, why you're supplementing them, why you're recommending a certain diet. People, when they see things, in an objective way, like a DNA test or a blood test, they tend to follow your recommendations a whole lot more readily than if you're just saying, "Oh, I recommend doing this." So this is an important skill, and I think you'll learn a lot too by looking at people's genetic reports. I think it's kind of fascinating myself. I love going over these with patients for several reasons. One is I'm always curious, what am I going to see there? But they are too. Why am I the way I am? And it explains a lot in that category. And it's almost like you are, reading a crystal ball and telling them that, hey, this is why you're an entrepreneur. This is why you don't connect well to people, or you are too empathetic, or don't detox well. There's lots of things going on here, but the personality part of it is super fascinating, and almost always is right on. When we look at patients' personality results and their mood and personality results, and they talk to us about, yeah, I guess I've been beating myself up for that for a long time. It's really kind of amazing to see the shift in their beliefs about themselves, and I know it did for me too. And I think I've talked to you about my lifelong depression, and then having the DNA show me that, yeah, there's a reason for that I definitely had DNA variants that kept my brain from making neurotransmitters correctly. It was so relieving to me because I thought I was just, not trying hard enough, not doing the right things, not eating the right things, not thinking the right things, not doing enough emotional work or whatever. But it was incredibly comforting to me. And so that's my goal, especially with this first report, is to give them a sense of what I call genetic compassion for themselves. And then, leading them from that into, okay, it isn't like, "Oh, sucks to be you." It's like, "Hey, there's a lot we can do to change the expression of these genes," as we talked about in the last lecture. It is changeable, and it takes very targeted nutrition, and it helps if they're doing the right diet and lifestyle too, at the same time that they're taking the supplements and doing whatever else that you're guiding them to do, which is, getting adjusted, or doing emotional work, or doing exercise, or getting their sleep habits really balanced. So everything you do on top of this is really going to make the whole system work better overall, and they're going to get incredible results. When I started using this, one of the first things that really started to change very quickly were mood disorders. And I'm not talking about like gross, schizophrenias, although those did respond too. I'm talking about people coming back in and saying, I feel more content. I didn't realize I was stressed all the time, or I didn't realize I was depressed, or I didn't realize I was anxious. And now I just feel sort of calm, and content was the word that they used very often. And it happened very quickly when we start to implement the correct supplements in the right doses and the right forms for their genetics, and then add to it the dietary considerations. So with that, let's take a look at, I'm going to pull up here a report on MyHappyGenes, and we'll take a look at the mood and personality report here first. Now I'm going to be logging into my practitioner account. So I'm going to go and pull up my own report so that I don't violate anybody's HIPAA concerns or privacy concerns. All right, so we're going to share my screen. All right, here we go. So this is me. I don't mind sharing my information again once I found out that I was there was a genetic reason for it. It stopped me being embarrassed anymore about my mental health issues, and I'm okay admitting it and talking about it because I know that it wasn't me and it wasn't my fault. And it's an interesting thing, and this is something that you can talk to your patients about, is that, our biochemistry makes us feel a certain way. And when we feel that way, our brain tries to come up with a reason why we feel that way. And so for me, it was all about, well, I had a pretty rough childhood. I have alcoholic parents and my dad was mean, and we just sort of make up a story as to why would I be depressed. And it turned out to be, all of that was true, yes, but there are a lot of people in the world who that doesn't affect how they are in the world. It doesn't affect who they are, and it doesn't make them depressed for the rest of their lives. So, and again, with anxiety, if somebody's experiencing a lot of anxiety, they think that, oh, they have a more stressful life than other people, when it's simply not true. We're just making up stories that fit our physiology. And that's the fascinating thing, is those stories kind of go away. They don't go away. Maybe that's not the right term, but they cease having such a tremendous hold on us, or they cease to explain why we are the way we are. It's more about, yes, they influenced us for sure. I mean, I don't want to deny that trauma has a very real influence, and I've had my share of trauma. But once your brain chemistry is balanced, you can look at that trauma in a much more balanced way. And you can get to it with the therapies that we know how to do, like the EFT or the NET or emotion code, or whatever it is that you do in your practice. Whatever, if you use emotional work, you can get to them now once you get the brain chemistry sort of at a balanced level. You can go in there and change things really quickly, and that's really pretty awesome. So that being said, let's take a look at the mood and personality report, the first report. Now, remember that when you click on this, you're going to see checking report data version. It takes a few minutes because we're uploading 675,000 SNPs into the software program. That software program is now going to pull out 576 of those and adding. I'm always adding new genes, but it's going to show us, out of that bunch of software, or a bunch of information, we're pulling out a few genes, but it takes a minute to upload them. And just know that every time you pull up that report, it is updated. And that's why it takes a minute, because we do go back and we pull up the whole file. Anything we've added or changed or updated in there will be updated. So you're always going to have a current, accurate report going on. There's a nice little video here that explains how to read the reports, sort of an abbreviation. It's great for patients to watch, and you can watch it again just to remind yourselves. And this is important information for you to read and look at as well. But when we get to the sliders, what we did was we took all of the genes that are involved in, like, let's say, in an increased risk of alcohol addiction. In this category, these were all the genes where I found studies that said, yes, this gene has been shown to be present in those people that tend to be addicted to alcohol. And so we tally up how many homozygous variants you have, how many heterozygous variants you have, and how many normal variants or non-variant gene codes you have in each category. And then we tally them up, and then the slider moves to the left or right according to how many, what your score is in that category. And mine is a moderate risk. I'm not surprised, because as I mentioned earlier, my family were alcoholics. My dad especially, and my mom was sort of a high functioning alcoholic, but my dad was a bad alcoholic. And so I have a moderate risk, but I also have, is interesting, I have other genes that keep it difficult for me to handle drinking alcohol because I don't detox it well. So I think I was saved by the detoxification genes in this category. And then a high risk of moderate risk, I should say. When you're in the yellows, I call it moderate along the slider here. If you get into the reds, of course, that's a very high risk, and green is low risk. But a moderate risk of nicotine addiction, and everybody in my family smoked cigarettes. Luckily for me, it never took. I'm just was never attracted to it for whatever reason. And in opioids, again, when we're seeing something that's showing up in the middle there, even close to 50%, I would warn my patients, don't let them give you opioids. If you ever go in the hospital or your doctor gives you a pain pill, stay away from the opioids because you have a pretty robust risk of getting addicted to it. And this was true in my own case. Went into the hospital one time and they gave me Demerol and I just really liked it, maybe a little too much. So, I told them, oh, you don't ever give me any more of that because I liked it a little too much. And then when I saw, my opioid risk, I was like, no, it makes sense. Yeah, I can definitely see where people could get, boom, they can become addicted, especially if they went higher than this. They can get addicted very quickly because it just fills in those opioid receptors that are in the brain, just waiting for opioids, essentially. And this is, kind of an overall tendency for addictions. And luckily for me, overall, a little bit lower than moderate risk there. Not really, I'm not really an addictive type. I lucked out there. And this is anger, aggression, and irritability. And maybe you heard me talk about the MAO genes, and that's a big part of what we use to calculate this category. And for me, a little bit higher than moderate risk. And I can get a little anxious and irritable and aggressive if my program is off track. And so I kind of catch myself going, wow, I really got irritable here. I think my program is off balance. And so I go back and I look at my program and get it balanced back. And when it's balanced, I'm just really pretty mellow. I don't lose my temper very easily at all. So instead of looking at it as, gosh, what does it matter with me? Why am I so grouchy? What's really going on? I look at it as, oh, that's an indicator. It's a symptom. That's a symptom that my program, my biochemistry is off balance and I need to go back in and look at it. So we also look at the positive and negative aspects of each category. The positive would be having good boundaries and ability to speak up for yourself. If it's too high and it's out of balance, it's going to be quick temper and anger control issues and constant irritation at little things. So something to look at there. And this is the anxiety and stress imbalances. Again, for me, moderate. I don't really consider myself to be anxious. And this is really interesting because, I'll talk to doctors around the country when I was teaching. And when we would find that they had a comped variant and I would ask them, do you tend to be anxious? And they're like, no, I don't think I'm anxious. Do you think I'm anxious? I don't really think I'm anxious. And, you can tell they're just coming out of their skin. And they don't realize it because that's the way they've always been. And they've learned to cope with it. Somehow they were self-medicating by trying to meditate more or just just dealing with their high level of like their brain going all the time. When we look back at why is this gene in our genome, often it was there because your ancestors were the scouts. They were the ones that were alert to any kind of danger that was happening. They were always sort of hyper aware of their environment. And these people tend to stay in what's called sympathetic dominance, in an anxious state all the time. They have difficulty relaxing and sleeping and kind of shutting it down. Their brain's just like all the time. And they're often very chatty. There's different genes here. There are quite a few genes. The main one that we look at is the COMT gene that can kind of contribute the most to this. And so when I see somebody who's got a lot of the homozygous comp variants, I go, wow, yeah, we're going to have to calm your nervous system down. And we do that again through targeted nutrition to get their nervous system to break down the adrenaline. When we look at the interactive chart, you can kind of see here this comp enzyme. What happened to my purple balloons here? I'm going to load that puppy up again because something is happening with my purple balloons. Okay, there they are. So when we look here at the COMT gene, the gene codes for that enzyme that breaks down adrenaline. And so if you have a genetic variant there, it's going to be sluggish in getting adrenaline out of the system and cause your adrenals to kind of back up and be in sympathy. Like the adrenaline is too high and norepinephrine is too high and dopamine is too high. And this can lead to anxiety and ADD or ADHD. So this is the way we look at these genetic variances. What are they doing in the body? And if you have a variant there, it's 99.9% of the time, it's going to slow down the enzyme that it's coding for and cause a backup of the substrate behind it. So this can lead to, the stress responses, and it's largely because the adrenaline is not getting out of the system. Same with estrogen and insulin. So this can cause estrogen-driven cancers. When we look at the hormone pathways, the hormone interactive pathways, we look at the COMT enzyme down here that breaks down these guys, 4-hydroxyestradiol and 16-hydroxyestradiol. And these are carcinogenic estrogen metabolites. So here's the enzyme that breaks them down into the non-carcinogenic estrogen metabolites. So you can see COMT has its role here in estrogen-driven cancers. So it's something that we definitely want to pay attention to. And we'll be looking at that when we look at the gene table. We'll be checking on those kind of genes, but just know that that's what is largely in this anxiety and stress imbalances. It's going to lead to other health issues as well. And this is attention and focus issues, ADD, ADHD kinds of things. A positive aspect of this might be your ability to multitask. Negative would be inability to focus and complete tasks. And this is brain function and thought disorders or schizophrenia. And it's fascinating to me that we have so many genes for schizophrenia in our genome. That just fascinates me as to wondering why they're there. What was the advantage of our ancestors in having those genes in our genome? And then this was my depression report. This is the major depressive disorder. And you can see I'm way up here in the orange, which means that it's a very high risk. And there are the genes associated with major depressive disorder there. And again, that was, to me, very comforting because I'm like, wow, okay, there's a reason why I've been feeling this way most of my life. And there's hope that I can do something about it. And that is so important, is giving your patients hope that, yeah, okay, well, here's the compassion piece, but here's also answers for getting you beyond this. And this is seasonal affective disorder. So this is, sad. And I have a moderate risk there too. That's why I like living in Florida, because I really do need the sunshine. It does help my mood quite a bit. And this is sort of a mild depression. So there are different category, 3 different categories we look at. This one is more mild, has different genes and quite a few genes that we can look at that will contribute to depression. And this one is more about seasonal affective, and this is major depressive disorder. So a few different categories there. This one is difficulty with social interaction and communication, and this has to do with autism and autism spectrum disorders. So we have different levels of risk for autism, and these are the genes that they have found are associated with that risk. MTHFR is probably the most well-studied in that category, MTRR also, the methylation genes. Oxytocin genes for their, if they can't respond to oxytocin, usually they can't form bonds really well. And then COMT is in here as well. And that has to do with like that anxiety that happens with autistic conditions or autism spectrum disorders. So you can kind of get an idea of where that comes from. And this one is difficulty forming relationships, shyness, introversion, but it really has to do with oxytocin. So it's a high risk means you have very low oxytocin. Low risk means that you have very high oxytocin and you form bonds very easily and you connect with people, but it also means you're empathetic, and maybe if it's way too much in the green, maybe too empathetic, like you feel other people's emotions a little too much, and you might need to make sure that you understand who you are apart from other people. A lot, I see this low risk down here in a lot of healthcare practitioners, and I'll ask them, do you have trouble with, getting not not being able to separate yourself from your patient, kind of feeling what they feel way too much, and they're like, oh my gosh, yeah. So it's important for these people to really protect themselves and have some alone time and kind of clear their energy fields. And this entrepreneurial tendencies, these genes right here, DRD3 and DRD4, tend to make the person think outside the box, and they have difficulty with authority, with following the rules, and tend to think about better ways to do things. And it's fascinating how accurate this is. It kind of makes me laugh because it really can tell you quite a bit about your personality. And I'll ask people that have, kind of high in the entrepreneurial tendencies, I'll say, you probably have difficulty following a recipe, that you usually have to add in extra things or try different variations. And they're like, yeah, it's so true. And then when I see the ones that are way in the green, I'll say, I bet you follow the directions very well. And you make, like, I'll see this in soldiers where they just follow the directions that their commanding officer gave them to the T. They don't deviate. And that's what they need to do to get things done. And so it's, we need all different kinds of people along the spectrum, but it's just fascinating to see how accurate it really is. And it is in our genes. And this one is hormone related mood swings in women. And I've gotten the question before, is like, what if it's in men? And you are going to have some of the same genes, but they're not going to cause that extreme fluctuations in your hormones like it does in women. But it is something to look at, and they do kind of pop up when we look at the male hormone imbalances in the Healthy Genes report. And this one is learning difficulties, dyslexias, etc. And so there are some specific genes that are associated with dyslexias there. This is mood swings or bipolar kind of risk. And novelty seeking or impulsivity. So if they're heading in this direction, there's the negative aspects can be difficulty holding down a job, remaining in relationships, or staying in one place for very long, and risk of infidelity because they always need something new. Positive aspects, curiosity, love of travel and exploration, and innovative thinking. So somewhere in the middle, a moderate amount is good because it keeps you learning and exploring, and but helps you stay on track with commitments. And then this is sort of perfectionist tendencies, but more OCD kind of risks, obsessive compulsive, if it goes into the red too much. Positive aspects here, if it's moderate, you'll want to have a sense of wanting to do a good job, good concentration to complete tasks and do things well, and a tendency to be neat and organized and responsible. Negative, if it goes too high, it's going to be a fear of germs or contamination, constant hand washing, unwanted, forbidden, or taboo thoughts, and having to have things in symmetrical or perfect order, and having to be perfect at all tasks and never quite finishing things. And this is the PTSD risk. Interesting genes down here that are associated with that. One of them is that comp gene that we talked about. And if you can imagine that people that have a higher level of stress hormones already, then they experience a trauma and their stress is going to be up here versus somebody who's down here and they just escalate to there and they go back down. This person tends to not be able to get those stress hormones out of their body. And there's some other genes here that kind of contribute to the formation of the PTSD responses. And then these are sleep disorders. And this can be circadian rhythm kind of disorders, being a night owl, etc., not being able to sleep all the way through the night. This is not sleep apnea. That's a whole nother concern. Alrighty, so then we're getting into the report chart here, and the green results here mean that you got the right code for that enzyme. The yellow means that you got one parent gave you the wrong code or a SNP for that enzyme, and the red means that both parents gave you a SNP for that enzyme. So the red ones are going to be reduced by about 70% of their normal function. That's a big hit. And so those are the ones we're going to pay the most attention to. However, the yellows can build up too. If you have a lot of yellows in a category, they can actually add up to an imbalance as well. And they do factor into our risk sliders. And so like a lot of yellows and a few reds can add up to showing, yeah, there's probably a high risk of an issue here. And so this SNP column here, these are possible variations in the DNA that relates to the changes in the body. The single nucleotide polymorphisms is what that stands for. The RSID is the number that was assigned to the Genome Project to identify each gene. So each SNP, each possible SNP has its own RSID so that you can identify that and so that research can be plugged into the right genetic variant. And then this is one of the main traits that are associated with that particular gene. And this category is the risk allele. This is the wrong code in your DNA that results in a disease risk, the potential wrong code that we're looking for. And then this is your results. So when we upload your DNA results, after you get your DNA test, you're going to see that whether or not you have the correct alleles or the wrong alleles, or one wrong allele or two wrong alleles or the right allele. And so this is your actual results from your DNA test. So over here, you're going to see, again, red, yellow, green, reds being the ones that we're going to pay most attention to as we go through. But I want to point out some things to you. So when you, let's open this guy here. So click on any of those gene codes and it'll open it up and it'll tell you what it does. So this is adenosine deaminase. This enzyme breaks down a molecule in our bodies called adenosine. This enzyme is produced mainly in the immune system cells called lymphocytes. These lymphoid tissues include the thymus, which is a gland located behind the breastbone. Ooh, thunder. And lymph nodes, which are found throughout the body. Lymphocytes are an important part of the immune system, which defends the body against potentially harmful invaders such as viruses or bacteria. So it's also an important molecule for regulating sleep, and levels in the adenosine in the brain increase the longer a person stays awake. Several studies have linked genetic variants in the ADA gene to differences in a certain time of brain activity that characterizes deep sleep called delta waves. Caffeine, as well as theophylline, has been found to antagonize adenosine receptors in the brain. Caffeine may be contraindicated in those with genetic variants. And so genetic variants are associated with an increased risk of these issues. And if you click on any of those, it'll take you right to where I found that study. I tried to find as good a study as I could get. These are PubMed studies. And PubMed has a pretty high bar when it comes to publishing studies. So I tried to get as much as possible National Library of Medicine or PubMed studies from National Institute of Health. And so everything I say in here is going to be backed up by a study. And if I couldn't find a study, then I didn't, a legitimate study, then I didn't include it in there. So that's true of all the genes in here. And here's a cute little trick. If you click on this little arrow over here under results and click it again, it'll bring all your reds, all your homozygous variants up to the top. So you can really kind of see those, in one kind of snapshot here. And you can start to talk to your patients about those. So when I go over the report with people, often I'll do this, and then I'll show them, how they can go in their own, they can sign into their own account and go in and start looking at these genes and the variants. And one thing to caution them about is don't get stuck on any one or two genes. And you saw that it takes about, 4 to 10 genes for each slider, for each characteristic. So it's never one gene, one characteristic. And if you've been looking at genetic reports that are like that, you've gotten wrong information. It's just never that way. There's always backup systems. And so we have to calculate how many genes they have in a category and what is their risk factor. And so that's why those sliders are so important to look at. But they can pop open these genes and look at COMT. COMT is one of the big ones, and it's going to have a big effect on the body. And it's got, all of these symptoms here. And they can start to look at that and go, oh, this is why I'm anxious all the time. Oh, this makes so much sense. And then there's some suggestions on some of these diet and lifestyle recommendations uh, things to avoid along the way, and foods to avoid. Green tea, for instance, and this one contraindicated. It'll slow down this enzyme even further and create more anxiety. And there's some other foods in here as well that can interfere with the function of that enzyme even further. So there's just a lot of information in here to look at. These are the DRD3s, and there's that entrepreneurial tendency that I was talking about. Here's the study. Polymorphism associated with entrepreneurships, evidence from dopamine receptor candidate genes. It's kind of fascinating how all of this works. A couple of genes that I want to point out because they're little troublemakers are these HLAs. These are histocompatibility antigens, and they play an integral role in the immune system and are predominantly expressed in antigen-presenting cells such as B lymphocytes, dendritic cells, and macrophages. And they can lead to some weird food reactions and autoimmune conditions. So they're supposedly a Neanderthal DNA, leftover Neanderthal DNA in our DNA, and they cause a little bit of a histocompatibility problem where our body attacks our own tissues. And so, if you pop some of these open, you can see like this one is associated with celiac disease, shrimp and peach allergies, multiple sclerosis, insulin-dependent diabetes mellitus, chronic hepatitis B, and Graves. So, be wise for these people to avoid gluten-containing products. So these are tricky little guys. This one is associated with possible adverse reaction to vaccine. I found an interesting study there on how it's in the era of personalized medicine, it'd be great help to map out a genome risk of each individual to evaluate the risk of developing an autoimmune condition with vaccines. So I thought that was a pretty interesting little study there. So some little troublemakers there when you see them. There's the MAO, that's the warrior gene that I was talking about. It's associated with aggression and irritability and depression as well. And on and on. So you can jump in here and start clicking on some of these genes and start studying them. And I would encourage you to get a copy of the interactive chart so that you can start to plug in the information in your brain into these genes. So there's the MAO right there. That guy associated with the breakdown of serotonin. So too low of functioning there can cause serotonin to go up too high and cause a lot of anxiety and irritability and ADD kind of symptoms. That VDR that maybe you've heard me talk about, that was the one I had inherited, that doesn't allow your brain to make dopamine or serotonin correctly, and so it can lead to depression. And then the COMT, causing a backup of adrenaline, noradrenaline, and dopamine. So there's, when we look at the genetic variants, we can look at them in context of these biochemical pathways and really start to understand what's happening with them and how they're affecting our brain. All right, so, and then, here's that VDR. I just want to show that one to you because that is a big troublemaker. Look at all the different risks there are when you have a genetic variant in the vitamin D receptor. Not only the low vitamin D levels, COVID risks, autoimmune disorders, all kinds of autoimmune, lupus, cancer risks, etc. So it's kind of a nasty, and it's associated with a lot of different dysfunctions, but it's so easy to fix when we get the right nutrients in there. It causes that receptor open up, and then vitamin D gets in, and now you've reduced the risk of all those different conditions. And that's how powerful this work is. All right, so that's the first report, and we will go to the next report on the next video.